Okay, so one of the big problems with this one is that the bases aren't the same, so I'm going to change them both to be 9. I could change them to be 3, but 9 is going to work better. And on the one side, I am trying to make it big so that it's easy to see. I've got that happening in the exponent. It's not that easy to see, but it's there. And then on the other side, I have 9 squared. That's to the power of x. So I'm going to squeeze the other step into here, and that's where I'm going to raise to the power of x. In other words, I'm just deleting those, and I'm adding in the x over there. When we're solving exponential equations, either our bases need to be the same, or our exponents need to be the same. In this case, bases are the same, so that means automatically that our exponents are the same. And that's divided by 3. And that is equals to 2x. And now we solve the quadratic equation. We're going to start by multiplying both sides by 3 to get rid of that. Gives us 6x. We know it's a quadratic equation because it's squared. And in order to solve a quadratic equation, we need to make the whole thing equal to 0. So I am going to shift that 6x over to the other side where we would be subtracting it. And you don't have to show that step. You can jump straight to the step over here. When we see any kind of squares or anything like that, we know we have to factorize. What is the first thing we look for?
Common factor.
Well done. So we have a common factor of x. We take it out. X minus 5. The whole thing behind quadratic equations is that if the one factor equals 0, then the equation's true. And if the other factor equals 0, then the equation's true. So this factor is x. Let's make it equal to 0. And the other factor is x minus 5. And that's equal to 0. Those arrows you wouldn't draw. I'm just drawing them because I'm a teacher. And then we find out that x is equals to 5. So that means that x either has a value of 0 or it has a value of 5. It's not 0 and 5 at the same time. It's either 0 or it's 5.